So here's the reason why a to the power x to the power y is actually just the same as a to the power xy. And the way I'm going to show you that this is the same as that is by writing this out the long way. So a to the power x to the power y is basically written like this: a to the power x times a to the power x times a to the power x y times over. You're going to have y lots of these a to the x's. Now, if that's hard to imagine or understand, imagine we had a power 2 here instead. Imagine it said a to the power x just squared. That would just be a to the power x times a to the power x, because that's what squared means, times itself. So if you had a squared here or a 2 there, you would have two of these a to the x's. So if you got y there, you should have y lots of a to the x's. So that's the reason why this is the same as this. Now, earlier on, I proved that if you times two things that have powers, you add the powers. So I'm going to use that rule. I'm going to add the powers here. So I'm going to add all these x's together. So I'm going to get x plus x plus x plus x plus x. But how many of these x's do I have? Well, I've got y of these x's, right? I've got one of these x's for each of these a to the x's, and I've got y lots of a to the x's. So basically I've got x plus x plus x, y times over, like it says over here. Now, I think it's quite easy to see that if you've got y, lots of these x's adding together, then that is the same as just xy. Let me just explain it a little bit further, just in case that's a bit confusing. If I've got two x's, I write 2x. If I've got three x's, x plus x plus x, that's 3x, isn't it? So if I've got y of these x's adding together, that's xy, or yx if you want to, same thing really. So this bit here is equal to xy, and so you've got a already there, so it becomes a to the power xy, like I've got there. So in short, I've gone from here to there. I've shown you that this is the same as that, which is the same as that, which is just the same as that.